Hello everyone, welcome back to Nutrimentor, your companion for CPGET nutrition preparation. In today's session, we are going to discuss energy metabolism, one of the most important and repeatedly asked topics in the exam. From ATP to glycolysis, Krebs cycle to ketone bodies, we'll learn everything in a simple and exam-oriented way. So let's begin the journey of energy inside the cell. So the very first question is energy currency of the cell is, and the options are ATP, ATP, AMP, or NADH. Let's start with an easy one. Imagine your body is a giant company. Every activity from blinking your eyes to taking notes for CPG needs energy. But which molecule actually pays the energy bill inside the cell? Think carefully. And the right answer is ATP. ATP is the immediate source of usable energy for almost all cellular activities. Glycolysis takes place in and the options are nucleus, mitochondria, cytoplasm, ribosome. Many students automatically choose mitochondria whenever they hear energy production. But here is the trap. Does glycolysis actually begins there? Or does it start somewhere else first? Think. And the right answer is cytoplasm. Glycolysis occurs in cytoplasm and is the first step of glucose breakdown. Which pathway can occur even in absence of oxygen? And the options are citric acid cycle, electron transport chain, glycolysis, or is it beta-oxidation? Suppose you are running late and sprinting to catch a bus. Your muscles need energy faster than oxygen can be supplied. Which pathway keeps working even without oxygen? This is a classic entrance exam question. And the right answer is glycolysis. Glycolysis can proceed with or without oxygen. Here is another question. During anaerobic metabolism in muscles, pyruvate is converted into, and the options are acetyl-CoA, lactate, glycogen, ketone bodies. Ever felt a burning sensation during intense exercise? Your muscles are trying to tell you something. When oxygen becomes limited, which compound starts accumulating? And the right answer is lactate. When oxygen is limited, pyruvate is converted into lactate. The Cori cycle occurs mainly between options are liver and muscle, liver and kidney, heart and lung, muscles and brain. This question is all about teamwork inside the body. Muscles send lactate away and another organ helps recycle it back into the glucose. Which organ is helping the muscle here? And the right answer is liver and muscle. The Cori cycle converts lactates from muscles back into the glucose in liver. Which organelle is known as powerhouse of the cell? Options are nucleus, Golgi apparatus, mitochondria, lysosome. If ATP is money, then which organelle is the factory printing that money? This question has been around for decades and examiners still love asking this question. The right answer is mitochondria. Most ATP production occurs in mitochondria. The rate limiting enzyme of glycolysis is it hexokinase, phosphofructokinase 1 or PFK1, pyruvate kinase or lactase? High yield alert. Students often confuse hexokinase and PFK1. But if the exam asks for the rate limiting enzyme of glycolysis, there is only one correct answer. Yes, you are guessing it right. The answer is phosphofructokinase 1 or PFK1. It is a major regulatory and rate limiting enzyme of glycolysis. Which vitamin is a component of coenzyme A? Is it vitamin B1, B2, B5 or B12? Here is a favorite question, connecting vitamin and metabolism. Coenzyme A participates almost everywhere in energy metabolism. But which vitamin is hiding inside its structure? And the right answer is vitamin B5 or pantothenic acid. It is the structural component of coenzyme A. The citric acid cycle is also known as, and the options are urea cycle, Cori cycle, Krebs cycle, glycosylate cycle. Three names, one pathway. Citric acid cycle, PCA cycle, and Krebs cycle. If you know one, you know them all. And the right answer is Krebs cycle. Citric acid cycle and Krebs cycles are the same pathway. Which coenzyme carry hydrogen and electrons during metabolism? ATP and ADP, DNA and RNA, NAD and FAD, calcium and magnesium. Think of ATP production as a delivery business. Which molecule act like delivery trucks carrying energy-packed electrons to ATP-producing machinery? And the right answer is NAD and FAD. NAD and FAD transport electrons to the electron transport chain. Which pathway breaks down fatty acids to produce energy? Options are lipogenesis, glycogenesis, beta-oxidation, gluconeogenesis. When carbohydrate stores starts falling, the body opens its fat bank account. Which pathway begins breaking down stored fatty acid to release energy? And you are guessing it right. The right answer is beta-oxidation. Beta-oxidation converts fatty acid into acetyl-CoA for energy production. Ketone bodies are produced mainly during, options are excess carbohydrate intake, fasting and starvation, excess water intake, high vitamin intake. What happens when glucose becomes scarce? The body creates a backup fuel to keep important organs running. What are these special molecules called? And the right answer is fasting and starvation. Ketone body serves as an alternative fuel when glucose availability is low. Gluconeogenesis is the formation of glucose from, options are glucose only, non-carbohydrate sources, fat only, vitamins. No carbohydrate available, the body doesn't give up. It has clever mechanism to manufacture glucose from other materials. Do you remember its name? Glucose can be synthesized from lactate, glycerol, and amino acid. And the right answer over here is non-carbohydrate sources. Which micronutrient provides the highest energy per gram? Options are carbohydrate, protein, fat, fiber. This one should take less than 2 seconds. Which nutrient gives the maximum energy per gram? If you get this wrong, your nutrition textbook may be disappointed. Yes, the right answer is fat. Fat provides 9 kilocalories per gram, the highest among all macronutrients. BMR stands for, and the options are basal metabolic rate, body mass ratio, basic metabolic response, body metabolic requirement. Imagine you are lying in bed and doing nothing. No walking, no studying, no exercise, yet your heart is beating and your lungs are working. What do we call the energy needed for these essential functions? Yes, the right answer is basal metabolic rate. BMR is the minimum energy required to maintain vital function at complete rest. So here is the summary table. Let's quickly revise the topic energy metabolism. So glycolysis happens in cytosol, and remember the rate limiting enzyme is PFK. It gives pyruvate, ATP and NADH. Next comes pyruvate oxidation inside the mitochondria, where pyruvate converted into acetyl-CoA, the entry ticket to Krebs cycle. The Krebs cycle, also called as TCA cycle, is a powerhouse pathway that generates NADH, FADH, and ATP, equivalents for energy production. The electron transport chain is located on the inner mitochondrial membrane and produces the majority of ATP. Think of it as a final ATP factory. During fasting, gluconeogenesis helps maintain blood glucose level by making glucose from non-carbohydrate sources. So when glucose is abundant, glycogenesis stores it as glycogen in liver and muscle. When energy is needed, glycogenolysis breaks glycogen back into glucose for quick use. The pentose phosphate pathway or HMP shunt is important because it produces NADPH and ribose 5-phosphate for lipid and DNA synthesis. When body starts burning fat, beta-oxidation converts fatty acid into acetyl-CoA, generating a large amount of energy. And finally, during prolonged fasting or starvation, the liver produces ketone bodies, acetoacetate, beta-hydroxybutyrate, and acetone, which serves as an alternative fuel for the brain and heart. So, and with this, we have completed energy metabolism. Revise these questions once again before your exam because concepts like glycolysis, Krebs cycle, ketone bodies, and BMR are highly important. If you found this session useful, do subscribe to Nutrimentor for more CPGET preparation video. See you in the next class. Thank you.